Hello everyone, we are at Moscone Center, San Francisco, Intel Developers Forum, IDF16 here in California. And Algo-Logic here with CEO has something to show and share with us. I know them for a few years right now, so cannot wait to know what is this. And you are welcome to listen. Hello John, how are you today?
Hi Olga, doing just fine, thanks.
I see exciting equipment here you want to share with us, and the boards, and something new you're using with Intel.
Right.
So would you please tell us more about it?
Yeah, sure. So today that we're showing a low latency key value store that we have running in an Intel Xeon plus FPGA platform. And so the key value store is a way over the network that you can associate, say, keys with values like names and numbers, like IP numbers and addresses, hashes and blocks, stock market orders and sides, if you're doing graph search, edges, vertices, etc. And so the key value store that we built is implemented completely in an FPGA. And we'll talk about how we use that for this application. Is that we have the Intel Xeon with FPGA, and the key value store here runs inside of the FPGA. We also have a discrete Altera card where the key value store runs in the FPGA there. And in both cases, the input data for this is being fed from a 10 gigabit Ethernet switch from live streaming sensors that are writing data into these key value stores. And so the benefit of using the FPGA is latency, is that you can get a lot of throughput and very low latency by using an FPGA. And so we measured the same application with Linux sockets, where in user space, the application that needed 41 microseconds to access data out of the key value store was reduced down to 6 microseconds if we do kernel bypass, but it gets reduced another factor of 10 down to half a microsecond if we use the FPGA. And so that the application we're showing here is using a half microsecond latency key value store by offloading it into the FPGA. And so the demo that we have is using our Black Diamond system, which is a data acquisition system, and it can do continuous real-time monitoring from any type of different sensors. And so if you're doing a factory and you have manufacturing process control, you want to do real-time monitoring, oil and gas, that there's inputs that come from sonar reflections. If you're doing sensing with pressures or temperatures or strain or power, current and voltage, is that all of these are analog inputs that can be fed in from the real world, and you want to fuse these inputs together to make sense out of what's going on. And so the demonstration we have is we have an acceleration, which is a tri-axis accelerometer. We have a strain gauge, which is a hand sensor that we can squeeze. We have the weight, which is a scale that we can step on. And we have a temperature sensor. And all of these sensors are feeding into the Black Diamond system, which is like an internet-attached device that can output key value writes to our databases. We've got 2 key value stores running, one in the Xeon Intel package and the other on a discrete FPGA card. We're doing classification, where we're doing scaling of the input sensors, that is a weighted function of the values to determine a matching coefficient, which in AI terms is called the convolution of middle layers on the Xeon core, and we have a live dashboard which is showing us the output of this. And so the primary inputs, we'll start using them. And so, Olga, if you can have
Let me model that for you.
And
So this is the scale.
Bounces up and down, is that you can see that our weight is modulating. You go one step further.
Okay.
If you squeeze this,
All right.
this way,
I don't know if I can squeeze it. This is pretty heavy metal.
see that there's a
Oh,
strain
it
gauge
does
there.
feel it. Wow.
and then lastly, I'll shake
This is
for you.
stainless steel.
Is that with the accelerometer, is that if we turn and twist and shake this box,
It shows right away.
you can see that it's picking up the acceleration and motion in X, Y, and Z directions.
Wow.
So let's go back to using the strain gauge and scale. And so if you, again, squeeze it that way and jump, you can see that there's the weight and strain now are inputs coming in live from the sensors. And these are the primary inputs to the system. And these are live real-time data streaming in, being written into the key value store. And then over here we have matching coefficients. So Z1 and Z2 are derived functions that as Olga was jumping on the scale and was modulating the signal, is that these Z1 and Z2 are calculating 2 different scored functions. And so the difference is that by classifying who's standing on the scale and how hard they can squeeze, you can determine if it's someone like Hulk Hogan, which is heavy and strong, or someone little like Pee Wee Herman,
Or like me.
light and weak, or Olga, that's light and light and not as strong as Hulk Hogan. And so that these matching coefficients then will give you a score indicating who's most likely in the system. And so, again, the idea of having this is that with tens of thousands of inputs, trying to make sense out of all this data in real time is the challenge. And with the Algo-Logic key value store that has a half microsecond of latency, is that you're able to do real-time analytics and get results instantly, like in millionths of a second.
So you showed this here. What is there?
Right, so this is the Intel 2U server that has the combination of the Xeon plus the MCP FPGA. We also have the external FPGA card. We have fiber optic cables doing 10 gigabit Ethernet. And so these cables are feeding out of an Ethernet switch. And we have our IoT device, which is collecting the sensor input, and it's feeding the key value store. So the data is coming in from the IoT device through the Ethernet switch, being written into the two key value stores, and then the Xeon is plotting and doing the analytics to show us the values on the dashboard.
So you started to use FPGAs because it's give you lowest latency and kind of least processing energy?
Yeah, so one huge benefit of the FPGA is latency, is that our products get used pretty widely on Wall Street because for doing trading systems, latency is everything. And so having a half microsecond latency is about 1,000 times faster than the millisecond latencies that other database companies often talk about. And so it's 3 orders of magnitude faster. There is also advantages of throughput. And so our key value store with 40 gigabit Ethernet minimum size keys can handle 150 million reads per second. 150 million, which is, again, another factor about 100 more than the next best competition. And then in terms of power is that the FPGA system, typically the FPGAs use less than 25 watts or so of power. That would be a lot. And so, whereas doing things in a scale-out system with software could be using kilowatts. So there's factors of 10 to 100 savings in latency, throughput, and power.
Yeah, you wouldn't overheat those big computer centers.
That's right. So keeping the power under control is important.
So you are here at IDF. How did you like to be present at the conference?
Oh, it's been a great conference. There's a lot of new technology. This new Xeon platform just came out a month ago for developers, and so we've been happy to be one of the first developers to bring the system up and running. I think some of the other technologies that we're seeing here are just fantastic.
Wow, great. So you don't wait for directions, you just keep doing already. In 1 month you develop something interesting.
Yeah, I think our developers are very capable of doing fast prototypes, and so we put this together system very quickly to show the capability.
And what would be your wishes to our viewers?
I hope that they can think if they have a need for collecting or processing data from a lot of inputs or sharing data over the network, is that think about our key value store as a way to have instant access from anywhere in the network from tens of thousands of things where they can be writing millions of times per second and be reading millions of times per second without having delays or jitter that you typically have from a software system.
And it's probably much cheaper with doing that, no?
Yeah, it's very cost effective because we can offload that computation to the FPGA. Is that device is very well suited for doing that computation. So it's a very, this could be used on drones, it could be used in automobiles, it could be used in data centers where, in a data center you might need to scale this out because you've got a lot more data, but still, as you scale this out, it still gives you a really cost-effective way to do it.
Until then, Algo-Logic.com, algorithm, remember algorithms there, and logic all together. So follow up with Olga Media and Algo-Logic.com.